Good evening, Udaina. How are you?
I am fine.
Okay, great. You studied the lesson well?
Yes, let me
Okay,
see.
great, Udaina. Okay, you hear me, Udaina, clearly?
Yes, please. See you.
Okay, 1 minute, there is a problem on a share. Okay. Yes, thank you. Okay. Yes, I'm with you. Now, today we will talk about lesson 2, inshallah, law of lever, okay? But first we wanted to make a quick revision for our lesson, the last lesson, okay? You remember it?
Yes.
Okay. Rudaina,
Okay,
tell me
miss.
what is, yeah, okay, let's begin. Okay, tell me what is the structure of liver? Tell me the structure of liver.
The structure of liver.
Yes,
It's a rigid bar that works
structure.
around a
Yes.
fixed
No,
point or
listen to me.
circle.
I talk about structure. This means that I don't want to, the definition of liver. I wanted to know the structure of liver. Okay?
Structure. Okay.
Hmm?
Uh,
With me, Saleh and Rudaina and Hannah. That's right. Welcome. Okay, tell me, Rudaina, again.
okay.
Huh?
It's a structure.
Yes.
It's
Structure consists of
types
what?
of liver or not.
Structure. It consists of, any liver consists of 3 main parts.
Distance force and effort force and the fulcrum.
Yes, that's right. This is, we called it the structure of the liver. Consists of 3 main parts, which are vacuum, resistance force, and effort force. Thank you. Saleh. Saleh, Saleh, tell me, what is the meaning of resistance force?
It is the force that results from the weight of the ball that we want to move.
Great, more than excellent. Hannah. Hannah.
Yes.
Hannah. Tell me, Hannah, what is the meaning of first class liver?
They are levers which have fulcrum in the middle
Between?
between the resistance force and effort force.
Great. they are levers that have a fulcrum between an effort force and resistance force. That's
And
right.
it sometimes save effort.
What? Yes. Okay. Thank you.
And sometimes
That's
save
right.
effort.
Okay. Give me example for the first class lever. You can? Hannah, you can? Give me example for first class lever.
Okay. Like seesaw.
Seesaw, that's right. What else?
And scissors.
And scissors, that's right. Only Saleh, Rudaina, and Hannah. There is another one. Only 3. That's right.
No,
Yes.
teacher, there is no anyone.
Okay. Fine. Okay, Rudaina, tell me what is the meaning of second class lever?
It's a lever that has resistance force between fulcrum and effort force.
Great. Resistance between fulcrum and effort force. Give me example for second class lever.
Nutcracker,
Great.
nutcracker, and water opener.
Great. That's right. Okay, thank you, ya Hannah, ya Rudaina, thank you. Saleh, tell me the third class lever, what is the meaning of it?
They are levers that have the effort force between the resistance force and the fulcrum, and it always doesn't save effort.
I want
And
to talk about
example is
no.
ice holder and map.
Ice holder and
Hockey bat.
keypad, that's right. Ice holder, manual prompts, a sweet holder, tweezers, all of them, it's from the third class lever, that's right. Today, inshallah, we will talk about the law of lever, okay? What's the meaning of law? It's A, sorry, not O, law of lever, okay? Law of lever, effort force multiply its arm equal resistance force multiply its arm or by its arm. This is a law, okay? So we wanted to describe this law now, okay? We will make an experiment together to describe this law, okay? Ready? Great.
Yes,
Six.
miss.
Great.
Ready, teacher. Let's start.
Okay. Let's start. Okay.
We learned from the last lesson that levers are simple machines. In this lesson, we will study something called law of levers. Let us discover together in our experiment how to deduce the law of levers.
Okay, let's start. Okay. First, we will hang a metal rod like that. Here we hang it in a fixed point. You see the fixed point?
Drag the bag and fix it at the right end of the metal rod.
Okay. We will drag here the bag. Okay. Sorry. Okay. On the right.
Drag the spring balance and fix it at the other end. Click on the spring balance to pull it onto.
You know the spring balance? We talk about its first term. You know it? You know the spring balance? Okay. We have a bag, okay, and spring balance. Okay. Okay. We will move the spring balance to know the weight. Okay. The weight it means what? Means what?
Use the metallic metrical ruler to measure the distance between force and fulcrum. This indicates the arm of force.
The weight, it means what, Yorid? What's the means?
We learned from the last lesson that levers are simple machines. In this lesson, we will study something called law of levers. Let us discover together in our experiment how to deduce the law of levers.
Okay, let's start it again. Please take care.
Drag the metal rod and hang it from its middle to this fixed point.
Okay, we will hang it in a fixed point like that.
Drag the bag and fix it at the right end of the metal rod.
Okay, here.
Drag the spring balance and fix it at the other end. Click on the spring balance.
Okay, as you see, when we click on the spring balance, we will find the force is equal 50 Newton. Any problem till this point? Any problem?
No.
Okay, all of you hear it well and see it well? Okay.
Yes.
Okay, great.
Use the metallic metrical ruler to measure the distance between force and fulcrum. This indicates the arm of force.
Okay. Here, this is the distance between the fulcrum, it's a fixed point, and the force, we called it what? It equal 40 centimeter. Okay, it called it 40 centimeter. Okay, let's measure the another distance between the fulcrum and the back.
Use the wooden metrical ruler to measure the distance between the resistance and the fulcrum. This
is 40 centimeter. Okay.
In the previous observation, the metal rod was balanced. When we look at this table, we find that the result of force multiplied by its arm is equal to the result of resistance multiplied by its arm.
Okay, let's see. Here the force is 50 Newton. Okay, arm of the force we measured by the ruler is 40 centimeter. The force by Newton and the distance by the two arms by centimeter. طب resistance equal 50 also Newton. طيب الarm of resistance 50 centimeter. We will apply the law of lever. Force by its arm equal the resistance by its arm. This means this is a balance. This is a balance. Both of them equal 2000. The force by its arm equal the resistance by its arm. This means this experiment to prove the law of lever. You understand me, grade 6? Any problem till now? Both of them equal 2000. This means it apply the law of lever. Any problem till this point? Huh? Any problem?
No, teacher.
All of you understand this point? Okay.
Effort force arm. It is the distance between the effort force and the fulcrum. Resistance arm. It is the distance between resistance and fulcrum. The law of levers is the effort force multiplied by its arm, which equals the resistance multiplied by its arm.
Okay, here we have an effort force, and here we have a resistance force, the weight of the body. Okay, the distance, you see it, the distance between the fulcrum, this distance between the fulcrum and the effort force, we called it arm of the force, which is measured by centimeter. And also here, D2, the distance between the fulcrum and the resistance force, we called it what? Arm of resistance. And also we measured by centimeter. Okay? So here, this is a law of the lever. Effort force by its arm equal resistance force by its arm. Any problem till this point? Grade 6?
No, miss.
You understand this point? Okay.
Yes.
Let's explain it. Let's explain it more. Explain it again. Okay. We want to now to know what is the meaning of force R. What is the meaning of resistance R? Okay, let's see.
We know that law of levers states that resistance multiplied by its arm equals force multiplied by its arm. Let us apply this rule on the seesaw as one of the examples of levers.
Okay, we have here resistance, and we know the meaning of resistance.
Resistance is symbolized by the letter R. It is the force that results from the weight of the body that we want to move.
This means when we found word weight, this means it's a resistant force. It is the force of the force that resulted from the weight of the body that we wanted to move. But what about the arm of resistance? Anyone tell me what is the definition of arm of resistance? Rudaina, you can? Rudaina, you can?
Yes.
Okay, what's the meaning of arm of resistance?
It's a distance between the resistance force and fulcrum.
Great, that's right, more than excellent.
We call it the arm of resistance. It is the distance between the resistance force and the fulcrum.
Great, it is the arm of resistance. This is the distance between the resistance force and fulcrum. We called it what? Arm of resistance. Okay, Saleh, can you explain to me what the meaning of arm of force? The definition of it?
It's
Arm force.
it is the distance between the arm that is it's the distance between the effort and the
Again, sorry, I can't hear clearly. Again, sorry.
it is the distance that is between the effort force and the fulcrum.
Great, that's right. Distance between the effort force and fulcrum. That's right. Thank you. Rudain, Hannah, let's listen to it.
We call it the arm of force. It is the distance between the effort force and the fulcrum.
Great. What about the effort force, yeah, Hannah? You can tell me what is the definition of effort force?
Effort force.
Yes.
It is the force that it is the force which uses the effort on the lever.
No, I want a definition of effort force.
Teacher, can I see, please?
1 minute. Hannah, you can? Hannah?
I can't.
Okay. Who come later? Who? Okay, Rudaina, Hannah, who? Sama? Sama, yes. Sama, tell me, what is the meaning of effort force? Sama, tell me. What's the meaning of effort force, ya Sama? Sama, you hear me? You can? Okay.
Sorry, no.
Rudaina. Okay, Rudaina, you can? What's the meaning of effort force? Rudaina?
Effort force.
Yes.
Teacher, I know it. Please, I'm Saleh.
Okay, Saleh, answer.
It is the effort that we do to move a weight.
The force that exerted by a person to equilibrate the resistance.
You can see we said at the beginning of the lesson
Okay. Okay, you understand me? Okay.
Effort force is symbolized by the letter F. It is the force exerted by the person to achieve the balance between it and the resistance.
To equilibrate the resistance or make a balance to the resistant force. Effort force, it is a force that exerted by a person to equilibrate or to balance the resistance. Any problem? Sama, Hannah, Rudaina, you understand this point?
Yes.
Any yes. Problem now? Okay, great. Any problem till this point? Okay. Okay, please listen carefully to this video because I will ask you after it. Please listen carefully.
Levers are simple machines that help us to make our life easier. Most of them conserve effort, while others do not. The law of levers is the effort force times its arm equal to the resistance force times its arm. This law can be applied on the three classes of levers to discover which type of levers conserve effort and which do not. In the first class of levers, fulcrum lies between resistance and force, so we have three possibilities of saving effort. This crowbar is an example of the first.
Take care. On the first class lever, as we see, the fulcrum located between effort force and resistance force. We have a three possibility in this type of lever. Please take care. I will ask you after the video. Okay.
First possibility. We will find in crowbar that the arm of force is shorter than the arm of resistance, and we will exert more effort to move the rock. So this type of levers does not save effort. When we look at the seesaw, we will find that the arm of resistance is equal to the arm of force, which means that the effort that we will exert is equal to the resistance. So, this type of levers does not save effort. The crowbar of the third possibility is different from the last one in the first possibility, because in the third possibility, the arm of force is longer than the arm of resistance, and that makes the exerted force less than the resistance. So this type of levers saves effort. In the second class of levers, resistance lies between fulcrum and force, so we have only one possibility. Here, in the nutcracker, the arm of force is longer than the arm of resistance, so the exerted effort is less than the resistance. So the second class of levers always saves effort. And finally, in the third type of levers, the force lies between resistance and fulcrum. It also has only one possibility. Look at this manual broom. We will find that the arm of force is shorter than the arm of resistance, which means that we have to exert more effort. So, this type of levers does not save effort. And now, let us see the summary of this video.
Okay. Okay, well, let's begin from Rudaina. Okay, Rudaina. Okay. 1 minute, Rudaina. Okay, you hear me, Rudaina?
Yes, Miss.
Rudaina? Okay, we talk about the first class level. There is three possibility of first class level. Tell me number one. We want to draw together, okay? Here, there is a fulcrum. Okay, on the first class level, the first possibility, what happened on it? Huh? Sorry, oh.
In the first class level,
we have a three possibility for the third class level. Three cases. Tell me any one from them. You can?
It's, yes, resistance force and effort force between resistance force and effort force between the fulcrum.
How? In all that the case of first class level, the fulcrum located between a resistance and effort. The difference only in the tool of the force arm and resistance arm only. Okay, talk about it, please, if you can. You can, يا رودينا?
No.
Okay, Saleh? Saleh?
Yes, teacher.
Tell me, the first case on the first class level.
The effort arm is longer than the resistance arm.
Great. Effort arm longer than. You mean force arm. That's right. Okay, here we will draw like that. This is a fulcrum, that's right. And this is a force arm. Okay. This is an effort. And this is a resistance arm. Okay. Here, this is R. This is a force arm. And this is a resistance arm. Okay, explain to me, ya Saleh. Here, the force arm larger than the resistance arm. So what happened for the force?
Again?
When the force arm larger than the resistance
it will
arm.
save.
What
I will
happened?
save it.
Okay, tell me.
When it will be saved.
No, I don't want to like that. I talk about the force. What about the force and resistance force? When the force arm larger than the resistance arm. What happened for the
That
force?
means that the force is smaller than the resistance.
This means what?
That the effort, the force is smaller than the
Yes.
resistance.
Yeah, this means effort force, okay,
Received.
smaller than resistance force. طب in this case, it save effort or doesn't save effort? In this
Sure.
case, it
It's
save
save
effort.
effort.
Save effort. يبقى you must know when the resistance force longer, the effort force longer than the resistance force. This is a longer. It's opposite to the force. This means the effort force will be smaller than the resistance force. When the force which I exerted is small, this means this type of lever will conserve effort. Okay? This means it has a mechanical benefit. It will save effort. This means it has a mechanical benefit. Any problem till this point? Any question?
No.
No, teacher.
Any question?
No, miss.
Yes. Okay, great. طيب, Hannah, you can tell me the second case of on the first class lever? Second case? There's another one come. We have Mu'min also. Great. تمام. Okay, Hannah, tell me the second case of the first class lever. We have number 1. Saleh, tell us number 1. Hannah, Hannah, sorry. Tell me the another case. Hannah, you can? Hannah?
No.
Why? طيب, Sama, you can tell me the second case?
The second
Sama?
what?
The second case on the first class lever.
Speed of case.
Possibility. We have a three cases. Okay, it may be that a force arm equals the resistance arm, or maybe a resistance arm larger than the force arm, or maybe a force arm larger than the
The first
resistance
class
arm.
lever, medium.
No, I know. All the cases, it's the force, the fulcrum located in the middle. I know, but sometimes the effort for force arm equals the resistance arm, and sometimes the force
The
arm.
first arm equal the resistance arm in the first class lever.
No, we have a 3 cases on first class. From them, sometimes the force arm larger than the resistance arm, sometimes the resistance arm larger than the force arm, sometimes they are equal. I want you to tell me one case and explain to me. You can?
No.
You can? طيب, Mu'min, you can?
Yes, miss.
Okay, you can explain to me one case from the first class level?
What?
One case or possibility from the first class level. You can?
I can't hear you.
You can explain to me one case or possibility from the first class level. We have a three possibility in this type. You can tell me one?
First class
Yes.
and first class level and second class level and third class level.
No. Okay, listen to me, please. On the first class level, there is a 3 cases or 3 possibility. Okay, all of you know that on the first class level, the fulcrum located between resistance force and effort force. Okay, right. Let's know together the first class level on the first possibility or the first case. Here, the fulcrum located between the effort force, okay, and resistance force. But here, as you see, here, this is distance, which we called it force R, and this distance, we called it what? Resistance R. Okay, right. Here, which one bigger? Which one bigger or larger? Which one, a resistant arm or a force arm? Which one? Which one larger than the other, resistance arm or force arm? Resistance arm larger than the force arm. That's right? Or longer?
Yeah, that means that is it's not.
Saleh,
Yes, teacher.
1 minute.
Yeah.
Close your
I
mic,
want to
please.
ask.
Listen to me. Okay?
Yeah.
When the resistance are larger than the force are, this means what? This means what? This means the effort force is it's larger than the resistant force. Effort force larger than the resistant force because its arm is smaller. Okay, this means this type of lever doesn't conserve effort because the effort force is larger than the resistant force. This means it doesn't conserve effort. Also, it's a first class lever, but it's one case on the first class lever. You get it? يبقى when the force R smaller than the resistance R, smaller than, this means the effort force larger than the resistance force. And this type of lever doesn't conserve effort and has no mechanical benefit. You understand me, Olet? Any problem till now?
Yes.
Sure. Any problem? Huh? There's any problem till this point?
No.
This is a first class lever or second or third? Huh? First or second or third?
First.
First, great.
First.
But it's a case from the first class level, okay, which doesn't conserve effort. So let's see another case. Okay, ready? Okay, let's see. So here, if the vacuum located here, okay, between an effort force and resistance force, this means which one bigger or longer, the force R or the resistance R? Which one longer? Huh? Which one longer? Rudaina.
The force R.
Great. Force R longer than the resistance R. That's right. This means what? The effort force will be what? The effort force will be larger than the resistance force or smaller than?
Larger than the resistance force.
What? No. Look, listen to me. Always arm opposite to the force. When the arm large, this means its force will be small. This means in this case, the effort force will be smaller than the resistance force. It's opposite to the arm. When the force arm large, the effort force will be smaller than the resistance force. This means this type of lever, because the effort force is small, it saves effort because I exert a small effort. For that, it saves effort, and has this case in the first class lever has a mechanical benefit because it saves effort. Do you understand me, Olet? You get it?
Yes, miss.
Any problem till this point? This is a case from the first class lever, but this case only in the first class lever save effort. Why? Because the force arm larger than the resistance arm, and this depends on the force arm, okay, smaller than the resistance arm. For that, this type of lever save effort. Why? Because I exert a small effort. You get it now? Any problem till this point?
No.
Okay, great. The third case, okay, let's see it together. Here, The fulcrum located at the middle exactly between the force and the resistance. Okay, this means the force R equal to the resistance R. It's equal. That's right. This means effort force equal to the resistance force. Okay. When both of them equal, this type of lever doesn't conserve effort and has no mechanical benefit. You understand me? Any problem till this point?
Yes.
Now
No.
we have
No.
three cases or three possibility of the first class lever. Only one of them save effort. Which one? When the force R is larger than the resistance R. In this case only. Why? Because the effort force will be smaller than the resistance of force. You get it now? Any problem till this
Yes.
point? Sure. Any problem? Hannah. Hannah?
Yes.
Hannah, with me? Okay, Hannah. Tell me,
Yes.
I want to now to draw the second class lever. Okay, I will draw it. Okay, tell me what can I do? I will draw rigid bar. Then what can I do then? This is a rigid bar.
You,
Okay,
you
then
will do the fulcrum.
where is the fulcrum? This is a second. Okay, where I can put a fulcrum? Where?
You can put it on the left.
Okay, I put it here.
Yes.
Okay, great. Top. At the middle.
The resistance force.
Great. Resistance force. I will put it here. Okay. Type. Where can I put the effort force? Here.
Effort force. The right.
Okay. Sorry. Okay. Let's draw it like this. Sorry. Okay. طيب. Tell me who Rudaina, I think Hannah. That's right. Which part is the force arm and which part is resistance arm? Hannah.
The
The distance between what and what, it's a resistance arm.
the resistance force and fulcrum.
No, listen to me. Where is the resistance arm located between what? Resistance arm.
Fulcrum and and resistance.
What? Again? Between what?
Between fulcrum
Okay,
and resistance.
great. Between fulcrum and resistance. This is, we called it what? Resistance arm. That's right. That's right. So
Yes.
where is the effort arm? The distance between? Quickly, Hannah. Hannah.
Yes.
The force arm. The distance between?
The distance between fulcrum and effort.
Great. Yeah, this is distance, that's right? The distance
Yes.
between the force and the fulcrum. This is, we called it what? Force R. That's right? Which one larger?
Yes.
Which one larger?
The largest arm is the force arm.
Great. This means force arm larger than the
Is
resistance arm. That's right? So what about the force?
Yes.
Which one bigger?
resistance force.
Larger than?
Larger than the effort force.
Great. Great, more than excellent. This means what? Resistance force larger than the effort force. This means this type of lever conserve effort or doesn't conserve effort?
Conserve.
Great, more than excellent يا Hannah, that's right. يبقى when the
Yes.
effort force is smaller than the resistance force, this means this type of lever conserve effort. Great, thank you يا Hannah. Thank you. Okay, Sama.
Yes.
What about
Yes.
so the class lever? I wanted to draw it together. Okay, ready? Okay, I will draw the result bar like that. Type. Tell me, I will put which I would put where the fulcrum or effort force or resistance force. Let's begin from the middle.
The
Huh?
effort force in the middle.
Great. Okay. Like that. Okay. تمام. Then.
The fulcrum.
Okay, I put it here. Okay.
The resistance.
Okay, let's put it here. Okay. تمام. Okay, tell me tell me where is the force R? The distance between?
Distance between the effort force and the fulcrum.
Great. You mean this distance? You mean this distance?
Effort R.
Yes. Okay. This is effort R. Okay. So what is about the resistance arm? Where? Located between?
The resistance force to the fulcrum. Resistance R.
Great. That's right. Okay. Which one larger?
The resistance R.
Great. Resistance R. Always larger force R. That's right. That's right.
Yeah.
Okay. This means
Yes.
that what about the force? About resistance force and effort force?
This class doesn't conserve effort.
No. I wanted to talk about the force. Which one is bigger than? Effort force or resistance force?
Resistance force.
Resistance force is larger than or effort force? Here, the resistance arm larger than the force arm. What about the force? Is the force opposite to the arm? Here, resistance arm larger. This means resistance force smaller than the effort force. This means the effort force larger than the resistance force. This type of lever, it's conserve effort?
No.
No, this type of lever doesn't conserve effort. Okay? يبقى this means okay, Saleh, tell us please which type of lever conserve effort and which doesn't conserve effort.
Conserve effort, second class lever, and sometimes the first class effort lever, and doesn't conserve third class lever always, and first class lever sometimes.
Great. First class lever on only one case save effort. Okay. Second class lever always conserve effort. Third class lever doesn't conserve effort. Type. Mu'min, tell me, give reason. The third class lever always doesn't conserve effort. Why? Mu'min,
Yes, miss.
you hear me?
Yes, can you hear me?
Yes. Tell me why the third class lever doesn't conserve effort.
Because
You can answer, ya Mu'min?
oh,
Rudaina, you can?
Teacher, can I say?
Again? Yes, give reason, sir. The class level always conserve effort. Why?
Doesn't
But
conserve
third class
effort.
lever doesn't conserve effort.
Yes,
Teacher
doesn't.
doesn't
I mean, yes, I mean doesn't. Sorry. Why it doesn't conserve effort? Sir, the class level.
Can I
answer?
Yes, Rudaina, you can?
7.
Sama. Okay, answer you some.
because the resistance R larger than effort R.
So,
That means the effort force bigger than the resistance force. This class level doesn't conserve effort.
great, that's right. Any problem till this point, يا ولاد? Any question? Any
No.
question?
No.
Sure? Okay.
Yes.
Sorry. I wanted you to see the video again because it talk about which we talk about it now. Please see it again and listen to it carefully. Okay?
Levers are simple machines that help us to make our life easier. Most of them conserve effort, while others do not. The law of levers is the effort force times its arm equal to the resistance force times its arm. This law can be applied on the 3 classes of levers to discover which type of levers conserve effort and which do not. In the first class of levers, fulcrum lies between resistance and force, so we have 3 possibilities of saving effort. This crowbar is an example of the first possibility. We will find in crowbar that the arm of force is shorter than the arm of resistance, and we will exert more effort to move the rock. So this type of levers does not save effort. When we look at the seesaw, we will find that the arm of resistance is equal to the arm of force, which means that the effort that we will exert is equal to the resistance. So, this type of levers does not save effort. The crowbar of the third possibility is different from the last one in the first possibility, because in the third possibility, the arm of force is longer than the arm of resistance, and that makes the exerted force less than the resistance. So this type of levers saves effort. In the second class of levers, resistance lies between fulcrum and force, so we have only one possibility. Here, in the nutcracker, the arm of force is longer than the arm of resistance, so the exerted effort is less than the resistance. So the second class of levers always saves effort. And finally, in the third type of levers, the force lies between resistance and fulcrum. It also has only one possibility. Look at this manual room. We will find that the arm of force is shorter than the arm of resistance, which means that we have to exert more effort. So, this type of levers does not save effort. And now, let us see the summary of this video.
Okay, I think it's clear. That's right. There is any problem till now? You get it now? Rudaina?
No, teacher. Yes, me.
Now?
No.
You can't understand?
Yes.
There is any problem?
No.
Okay, Rudaina, Hana, Mu'min, Sama, there is any problem till now? Saleh? Any question?
Yes.
Great. Great.
No, teacher.
Okay. Now we wanted to solve some problem on the law of levers. There is a problem, it's very important. Okay, I will give you example now to how to solve this type.
We learned that the law of levers is the effort force multiplied by its arm, which equals the resistance multiplied by its arm.
Okay, this
So
law.
let us apply the law of levers on the next example together.
Okay, this is a law of lever. You must save it to can save any problem. Okay, law of lever resistance force by its arm. The unit for measuring any force, it will be Newton. Okay, R, it will be centimeter. Okay, you get it now? Force, it will be Newton. The unit for measuring force. The unit for measuring arm, it will be centimeter. Okay, يا جماعة? Any problem till this point? Okay,
No, miss.
great. Let's see this example. Okay, here the exerted force of the first class lever equal 5 Newton, and the length of arm 20 centimeter. It is affected by resistance with a value of 200 Newton. 200 Newton. Calculate the value of the arm of resistance. Please, all of you, bring your pencil and your pen and try to answer quickly.
50.
No. Don't answer, please. Only write the rule, okay, and try to answer, okay, and I will choose one to explain to us, okay? Okay, quickly, please. All of you try to answer. Okay, I will give you only 3 seconds, okay? Quickly, please. Okay, ready? Ready? All of you finish?
Yes, it.
All of you finish?
Yes.
Great. Okay, let's begin with Sama. Sama, you can answer. Tell me first the rule. Sama? Sama? Sama, you hear me? Sama? Not here? Okay, Hannah? Hannah? Grade 6, you hear me?
Yes. Yes, teacher, I can hear you.
Okay, Hannah? Hannah here? Sama?
Yes.
Okay, Hannah, please tell me the rule first. Tell me the rule. Hannah? 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 Okay, Saleh?
Yes, teacher.
Okay, tell me the rule which we used to solve this problem.
Resistant force multiply its arm equal effort force multiply its arm.
Of levers
Great.
is force
Force.
multiplied by its arm equals resistance
And
multiplied.
first we will multiply 20 multiply 500 and it will be 10,000. We divide 10,000 divided by 200, it will be 50. And we have here 50 centimeter.
Great. Here, the problem gave us great. Thank you, Saleh.
And in this
There is a resistance.
example, it don't save effort. It don't save effort.
1 minute, please. Thank you, Saleh. Thank you. Okay, here we have a resistance 200 Newton, and also we have the force 500 Newton, and we have a resistance, the resistance for the force R, and we wanted to bring the resistance R. How we can calculate?
As we learned, the law of levers is that the force multiplied by its arm equals resistance multiplied by its arm. And from the givens, 500 multiplied by 20 equals 200 multiplied by the resistance arm. So the resistance arm equal 500 multiplied by 20 divided by 200. So the resistance arm equals 50 centimeters.
Okay, any problem till this point, Yoned? Anyone can't understand? Hannah, Raina, Sama, Mu'min, any problem? Here we have a force, force equal 500 as you see, 500 Newton. And here it's R given 20 centimeter. And we have the resistance here, 200 Newton. And we wanted to bring the arm. This means the arm, it's unknown. I wanted to bring it, okay? يبقى 500 multiply 20 divided 200 equal, you can calculate it. It will be 50 centimeter, okay? This is the answer. You understand me? Type. How we can know it's save effort or not? By 2 steps. First here, if the force larger than the resistance, Here the force 500 and resistance 200. This means it doesn't save effort. Or when we see that the arm 50 here, the resistance R, and here the force arm 20. When the resistance arm larger than the force arm, also you must know it doesn't conserve effort. From the force or from the arm? Any problem till this point?
No.
Any question? You can answer. We can answer this problem. Grade 6, you can?
Yes.
All of you can
Yes,
answer the
teacher.
problem? Okay, great.
Yes.
Oh, great. Okay. Okay. This is also problem. Okay.
Let us solve the following problem using the law of levers. Given that the distance between the two holes is 1 centimeter, find the position where you can place 1 Newton to balance the lever.
Okay, here we have, you can see that the distance between the hole, two hole, 1 centimeter, okay? Here we wanted to hang it another weight. This means we have the effort force, okay? It's only 1 Newton, okay? And we wanted to bring the resistance force, and we have the force R and resistance R. We can bring the resistance force. We can bring it. Anyone can answer? Hannah? Hannah, you can? Hannah?
Teacher, I can.
You can?
Miss all.
One minute. Mu'min, you can?
The law of levers is that effort force multiplied by its arm equals resistance force multiplied by its arm.
You can, يا صالح. يا مؤمن, sorry.
Yes.
Mu'min, you can?
Yes, miss.
You can?
I cannot.
You can solve this problem?
No.
Why? You didn't
Yes,
understand.
Teacher, can I go to the toilet? I am sorry.
Okay, يا صالح. Mu'min, you can answer the problem?
yes, miss.
Okay, please try to answer it. First, we will write the rule or the law. The effort force by its arm equal resistance force by its arm. Okay, tell me, we will solve it how? Where is the resistance and where is the effort? Okay, and we wanted to bring the resistance. Okay, tell me how we can solve it. Mu'min,
Yes, miss.
you can solve it? Think about it. طب okay, Rudaina, you can solve it?
No, I don't think.
Why? We have the resistance and we have the effort, okay? Let's see it together.
Given that the resistance force equals 1 Newton, effort force equals 1 Newton, and the arm of resistance equals 2 centimeters, and by applying the law of levers, effort force multiplied by its arm equals the resistance force multiplied by its arm.
Okay.
And that means 1 multiplied by arm of force equals 1 multiplied by 2, so the effort arm equals 2 centimeters.
Here only we wanted to bring the arm of the force. Only wanted to bring the arm of the force. Here we have the resistance 1 Newton. The effort also 1 Newton. Arm of resistance 2 centimeter. Right. How we can apply the law of lever? Effort force by its arm equal resistance force by its arm. Okay. The effort force 1. Its arm, we wanted to bring it. A resistance force 1. Its arm 2. How we can know it 2? Because the distance between the two holes 1. As the distance between the 3, it will be 2. You get it? Any problem till now? Grade 6.
Teacher.
Tell me. I repeat it again. Grade 6.
Yes, teacher.
I will repeat it again, or you understand it?
We understand this lesson.
Okay, great. Okay, great. طيب. Today, inshallah, I will send it to you the many problems. Okay, there is only the last answer. You will find it, but I wanted to write the step. Okay, تمام. I will send it to
Okay.
you that link, and you try to answer the problem. Okay, please
Right
answer
now,
now. What? Like now? Yes.
I'm asking you. Like,
By
but we have another question.
no, not now. After you finish all the session, okay, answer as a homework.
Can you send it to the group that is in the Teams?
Yes, I will send the link and you will answer it. Okay?
Okay.
Okay. This is the
To
lab.
Prime 6 or to
You,
Science group?
I will say no. Here you will make a submit. It will send it to me. Okay? This is all the only 5 problems. Please try to answer it. Okay? Please try to answer it. First, write the law or the rule of the lever, okay? Then found where is the weight, where is the resistance. Okay, I will try to explain to you number 1, and please try to answer the other because it's very important. It must come. You get it? It must come. It's very important. Okay? The body whose weight is 250 Newton set in a sisal, okay, at 3 meter from the fulcrum, where 150 Newton gears must set to balance the sisal. Okay? Now we want to bring here the effort force will be, and where is the resistant force? When we found the weight, this means this is the resistant force. يبقى this means resistant force equal 250. Okay? And it's R3. And here 150, it will be the effort force. And I wanted to bring the resistance, the force R. I wanted to bring the force R. Write the law and write the number and try to answer it. Okay? I wait for your answer. Please study well. Second time, there is a quiz on all unit 1. Okay? Okay, grade 6. Please study well. Second time, there is a quiz on all unit 1. Okay?
Okay.
Okay. Okay, please study well. And if there is any problem, please ask me. Okay? Okay, thank you, all of you. Please study and send your homework. I will send it to you the link now. Okay, thank you. Goodbye.
Goodbye.
Goodbye, thank you.